Okay. There we go. All right, so we're first going to look at, like I said, the cosecant and secant graphs, and then we'll get into the tangent, even though the table has it going different ways. All right, so first what I want you to do on your paper, hopefully from memory, is graph the sine graph. Make sure you do 2 periods of the function. This is the hard part, is graphing sine, when in reality, we are graphing cosecant. So watch how this works. If I am graphing sine, so I know sine at 0 is 0, so it's a 0 high, 0 low. If you've already drawn the actual wave, maybe go through and make it dotted by erasing a little bit. Forgot to mention that. Remember with rationals, when we were graphing those, when we would do the asymptotes? That's basically what we're drawing extra stuff before we can actually draw the actual graph itself. Okay. So like I said, that's the hardest part right there, is remembering how to graph sine. Okay. So then from there, if sine is cosecant flipped, what would that tell you about everywhere we're crossing the x-axis? Do it. I heard a couple different things. What do we end up dividing by? 0 makes it undefined. Okay. So if it makes it undefined, that's where those asymptotes come into play. So then everywhere I cross the x-axis, I have an asymptote. So like I said, you do more drawings before you actually draw the graph itself. But then here's the easy part. Now that you've created these asymptotes, it's really easy to draw your graph from here. All you're going to do is make little mini parabolas coming off of the vertices from the top and the bottom, and you just follow the asymptotes. So the blue lines are the graph. So if you plug this in the calculator, you would just see those little mini parabolas. That's all you would see. You wouldn't see all the dotted lines that we created. But we created those dotted lines so I don't have to get precise with any of my measurements. Okay. So let's look at that table. What's my domain? Looking at this graph. Thank you. You're welcome. It's not all real numbers. It's all real numbers except for where? Pi, 2 pi. So literally every pi. So a way to say that is going to be pi times however many numbers I want to put next to it. And that means a variable. So I'm just going to call it pi k. So x cannot be pi k, meaning I could plug in a 1, I get pi. I could plug in a 2, I get 2 pi. I could plug in a 3, I get 3 pi. So every pi, I'm not allowed to be, which means the asymptotes are at x equals pi k as well. What is my range looking at this graph? Do we have brackets anywhere? Do we include? Yeah, perfect. So negative infinity to negative 1 with a bracket, union 1 to infinity. Okay. Looking at our graph, what would be the period of the function? Two pi. We have to have the one that's going up, and we also have to have the one that's going down. Because remember, it's what can we take that we could copy paste, copy paste, copy paste. And we need one that goes up and then one that goes down. And I'm talking about those little parabolas there. So 2 pi. And I normally do this on the whiteboard where I have our graphs so I could go back and forth, but not having to switch back and forth like I am here. And then this is still symmetric about the origin, just like sine was. Okay. That is your cosecant graph. Okay, into our secant graph. So go ahead and graph on your paper the cosine graph and do the dashed lines for that. So basically all we've done so far is like for the cosecant graph, that's sine flipped. So you graph the sine function. And then if you think about if cosecant is sign flipped, then everywhere that it's zero, if we flip that, then we're divided by zero. So that's why we put asymptotes at everywhere it's zero. Then from there, you just draw the little mini parabolas within those limits. I'll leave that up here if you want to copy it down real quick while we're doing that other one. And that's all you've missed. Or better yet, you want to just take a picture of that. And it's on these notes too, but I don't know if you wanted to have them completed on there. Can I tell y'all when your state test is?
Yeah.
The 16th? Okay. At 8:30 in the morning. Wow, my ones and negative ones are way off. Look at that, this is clearly not drawn to scale.
That was my favorite. And I put that on
Huh?
like, I think it was like the 4-3 number. With the mountain and the car, it said in the corner, not drawn to scale.
You're like, oh, really? Who knew?
Yeah, sure.
That's not the distance of a car. Mine are never drawn to scale. All right, so if I grab cosine at 0 is 1, so I have my 1, 0, and then I go up from there, backwards. Same situation. If secant is cosine flipped, everywhere at 0, if I flip that, that becomes undefined. So I'm going to draw in my asymptotes at my zeros. Whoever teaches during the class that I have one, I guess during second, I don't remember if it's Miss Furman or someone different, gets to hear all my dash marks when I teach this lesson. They're like, oh gosh. So then from there, draw our mini parabolas. Okay, so let's think about our domain. What can x not be?
I carry.
So if it can't be at pi over 2, it's not like the last one where we can say, well, if we keep adding pi over 2, that gives us our next asymptote. What can we add that gets us our next asymptote? Do it.
Is it not? Never mind.
Pi, okay? So if I want to go from pi over 2 to 3 pi over 2, I have to add a whole pi, all right? So in order to start where I say my domain is. Yes, I'm going to say pi over 2, but then plus every pi k after that. So pi over 2, then I add pi to get to my next one, then I add another pi to get to my next one, and another pi to get to my next one. And then that's, of course, our asymptotes as well. And I can't remember if they use n instead of k in the book. I can't remember, but again, it's just a variable. I can't use x again because that is what our domain is. Your range is the same. I don't really have a lot of space here.
Don't worry, we don't either.
So that's the period of the function, except cosine in this case was even. Metric about the y-axis. So something you want to put on your notes. When doing transformations for these two, you do the transformations to sine and cosine, and then you just graph like we've been doing, okay? So if I gave you like 2 cosecant of x minus pi or something like that, okay? I would perform all the transformations I wanted to on sine, and then I would draw my asymptotes and then my many parabolas from there. So do the transformations to cosine and sine, and then graph it like we've been doing. Okay? All right, so tangent and cotangent. These are the little snakes, the little slivers, okay? Same idea. We're going to look at where we're dealing with where the function is undefined. And then we're going to, from there, it's going to be pretty straightforward on how to graph them. And again, that's why I said it seems like we spent a whole day on 2, and then here we are knocking out 4 like it's no big deal. Okay, so let's do the tangent graph. Set up your x-axis the same way we've been doing it. Oh, and before I forget, let's go back for a second. What's the amplitude of cosecant? What's the amplitude of cosecant? I'm sorry?
Infinity?
No, not infinity. Think about the definition of amplitude.
From the rest position
I'm sorry?
to the crest. Or the trough.
What did you say?
From the rest position to the crest or trough.
Okay. So what would it be?
My guess was infinity. Because it just keeps going.
Not infinity. It's the amplitude here,
Undefined.
not one. Most missed question on the test. And I say it every year, and it's still the most missed question on the test. You get caught up in taking the actual test, and you still make this mistake. We can't measure from here to here. We can't measure from here to here. We can't measure here to here. They're going other ways. So there is no amplitude for cosecant. There's no amplitude. You gotta speak up. You're hard
Say
about
it
it.
with your chest next time.
Right.
Speak at the same time.
Make y'all start raising your hands.
There's not enough of those in here.
Like, hey, I'm confident in my answer. It's none. Okay, so the amplitude is none. Same thing for secant. So we get caught up in the test and we're really getting after it, and something as simple as y equals 2 secant theta pops up. And I ask for the period and the amplitude. And you're like, I know where my amplitude is. It's always in the front. It has to be positive. Done. Okay? It gets people every year. All right? Amplitude is none. Okay? So secant, cosecant, amplitude is none. All right? I just didn't want to forget that. Okay, so that being said, what is tangent at 0? Okay? Which makes up here undefined and 0 and undefined. Okay, so let's plot what we know. 0, undefined, 0, undefined, 0. Backwards, undefined, 0, undefined, 0. Now, they can still have a vertical stretch and compression on both cosecant and secant, and they can still have, kind of giving it away on tangent too, can still have a vertical stretch and compression, but not necessarily an amplitude, okay? So, your tangent and cotangent graphs are gonna look the same, except the squiggly line's gonna go one way for one, and the squiggly line's gonna go the other way for the other one, okay? Quick and easy way to check which way your squiggly line goes. Okay, very, very mathematical here. All right. In between here, 0 to 2 pi, what quadrant is that in? Our first quadrant. Isn't everything positive in the first quadrant? Sine, cosine, tangent, all the things? So I want to make sure that I'm in the positives over there. So that tells me exactly how I'm going to draw my little, whoops, went past the asymptote there.
And you call yourself a math teacher.
Right? Okay. I'm getting hated on a bunch of my CP Algebra 2 class the other day.
Yeah. What you did?
Just typos and misspeaking.
Oh, well, that's on math.
Right?
That's math.
Yeah.
And you messed up.
Right. Thank you for keeping me humble.
You're welcome. It's what I'm here for.
I mean, it's only fair. I grade you, so you grade me, right?
Yes.
I'm gonna erase that because I feel like I can't go to bed tonight knowing that I made that mistake.
He's actually an administrator. It's just your.
Do it.
He's an administrator. This is your evaluation.
Right.
Thanks, though.
It's just school year.
We got evaluated in my class on Wednesday, or people in
It's like that TV show where his boss goes undercover.
Yeah.
That's exactly.
Yeah. Everyone else.
It's like the
It was a vertical evaluation on the, I watched it in my business class.
Great people.
Usually like boss undercover, it's undercover boss.
All right, so I kind of gave it away with the idea that, no, we do not have an amplitude here because it keeps going on forever, all right? So all 4 of these that we're learning today do not have an amplitude. Again, I can still have a vertical stretch and compression, but it does not change the amplitude because it does not have an amplitude, all right? Now, here's the thing. And don't put this on yours because I wanted to say the parent function on your actual notes. If there is an amplitude change, just as simple as it was to change things around with what we learned the other day, or an amplitude change, sorry, a vertical stretch or compression, just change this number 1 here to whatever that is. So if it goes by 2, and it's like 2 tangent, and just write a 2 there, okay? That way I know you acknowledge that there is a vertical stretch. But the only way you could really show that is if you put pi over 4 down here, and then you went up to that 2 and put a dot. Okay. So that's tangent. Let's go. So looking at this one, we have an asymptote at pi over 2 and 3 pi over 2. So that's very similar down here with secant. So tangent's going to have the same domain as secant. My range is what for those graphs? Now, look at the graph for a second. What distance do I need to be able to take one of those squigglies and copy paste it over and over again? Just pi, okay? So when you are looking at the period change, it's no longer 2 pi over b for those. It's pi over b. You take the original, okay? So when they're asking you to find the period of tangent, you're going to take pi over b. Okay, so that does change. And then, of course, looking at our graph, what are we symmetric about? The origin. So it's odd. Okay. All right. Let's knock out cotangent.
said it's like the exact same,
It's gonna look very similar.
so like the asymptotes and stuff.
If you think about it, our asymptotes are here, but then if we flip that, then it's gonna be basically what is a zero here is now an asymptote, what was an asymptote is now a zero, because you're taking a tangent and cotangent and flipping it. All right, so when we found tangent at 0, we do y over x, which would be 0 over 1, and we got 0. Okay, cotangent is that flip. So now this is my undefined, this is my 0. So it's tangent flipped. So basically, when you drew the tangent graph, whatever was a 0 is now an asymptote, and whatever was an asymptote is now 0. Switched. Okay, so undefined 0, 0. You will approach these problems the same exact way we did sine and cosine. If you had the period change in these, you would do pi over b, but you would still divide by 4 to set up your x-axis, okay? Now, let's look at that little token spot that we keep looking at. From 0 to pi over 2, everything is positive. So I need to make sure that my little squiggly line is positive in that first quadrant. So now my squiggly line goes the opposite direction. So right here, that's the first quadrant. So I have to be in the positive. Still don't have an amplitude. I can do a vertical stretch compression, but it does not have an amplitude. So if you look at your tangent graph versus your cotangent, I always like to go back and forth. It's like it's dancing. Whatever. Y'all will find humor later. It's like disco. All right, so let's go to our chart. If you notice, we have an asymptote that pops up every pi value. So this is going to be very similar to the cosecant. Still negative infinity to infinity. Still pi. Still odd. Okay. You'll still approach them the same way with the transformations, phase shifts, vertical stretch and compressions, moving things up and down, all that. Okay? Any questions so far?